Hello everyone, and welcome to today's Leetcode daily question, that is all paths from source to target. So basically, you have been given a direct acyclic graph, that is DAG, and this will be the visual representation of it. And the nodes will be labeled from 0 to n minus 1, and we have to find all the possible paths from node 0 to node n minus 1 and return them in any order. So so basically I've been given a graph, that is a 2D graph. So for example, here a 2D graph is given, that is 1 comma 2 3 3 and 0. So now what does 1 comma 2 tell us? So 1 comma 2 tells us that there is a path from node 0 to 1 and 2. Since it is a index 0, that means the node 0 has a path to index 1, that is 1, and index 2, that is node 2. So 0 has a path to 1 and 2. Now what does this 3 means? That is, at index 1 there is a 3. That means node 1 has only one path, that is to node 3. Similarly, at index 2, 2 has a path only to node 3. And the last one, the index 3, we do not have any path starting from here, so it is an empty list. So we will be simply using a DFS over here. So simply we will initialize the result, a list of integer. Then what we will do is we will define a list of integer called path. We will add a path, that is the first index, since we have to find the path from the zeroth index, zeroth node to n minus 1 node. So we will first add our first node, that is node 0. Then we will call a DFS function, and the parameters it will intake is the graph, a node that is initially 0, the result in the list which we will return at the end, and also the current path. So what does the DFS matrix do? So the DFS function does is simply that if the node we have reached the graph dot length minus 1, that is we have reached our destination, that is in this case 3. So we will simply add that current path, that is the path we have right now, to the the final result, and we will simply return from there. Else what we will do is that we will iterate through all the node associated with that particular node. That is, for node 0 we have all the nodes associated with node 0 is 1 and 2. So we will iterate through them, perform the depth first search, and we will add that node first, and after coming back we will remove them. So let me do a try run and explain you how it goes. So suppose this is our question. I've pasted the code over here. So simply now let's start our DFS function. So okay, we have defined. We will define a result list, and we will define a path, and then we will call the DFS after adding 0 to the path. So this is the result list of integer. Then what we do is that we define a list of integer called path. Okay, so we have a path over here, and we will add 0 to it. So we added a 0 to it, and then we will call the DFS search function. So with DFS, the DFS search function has currently the node as equal to 0. So node will be 0. So okay, so now that is we are at node 0 now with path 0, path consisting of only 0. So now what we will do, now since that node is not equal to graph dot length minus 1, that is the length of the graph is 1, 2, 3 and 4, that is 4. So it is now, since the node is not equal to length minus 1, that is 3. So we will iterate through all the all the nodes associated with the index, that is the node 0. So in the first list, in this is the list. So first we have a 1. So what we will do, we will simply add that to current path which we have, and then we will call the function with node is equal to 1. So okay, now we have path is currently 0, only 0. So we will call the DFS function with by adding a 1 to it. So we will add 1 to the current path. Okay, so the current path was 0, so now we added a 1, and we will call the DFS search function with 1. Now what we'll do again, we will move, this condition does not hold true, so we will again take all the nodes associated with index 1. So the nodes associated with index 1 is 3 and 2. Okay, so for now we will call a 3. So after adding it, so okay, we will add a 0 and a 0, 1 and 3 will be added. Since for this, the path is equal to 0, 1. Okay. So now we move to the third number, third node, and as we know, the third node is equal to graph dot length minus 1, right? So now what we will do is we will simply add whatever the path we had now current path to the result. So this path will be actually added to the result. So now this will have a 013. Result would have a 013 as one path. So we have added that to result. Now it will move back. Now we will be calling 2. So since the next element associated with 1 is 2. So now we will be calling a 2. And one thing to remember is that now while calling 2, we will first uh, remove the last element, the latest element added to the path. Now, what was the latest element added to the path? It was 3. So we will be deleting this 3 from the path, and then we will be adding 2 to it. So that is now our path will become 0, 1 and 2. Since we have deleted 3 and we have added the now we have added the next node, that is 2. Now we will be calling 2. Now 2 again has a part to 3. So now this will again call a 3. So again the path will now 3 will be added to the path. So the path now becomes 0, 1, 2, 3, and now we will move to 3. Now 3 again is the final node. So now this path will be added to the result matrix, and we will move back from here. Okay, so let me add. So we've added that path now. Now this will move to 2. Now since there are no more elements associated with 2, as it had only 3. So again if you move back to 1, now 1 has no more nodes left with it, since 3 and 2 were the only two. So now it will move back to 0. Now at 0, now the next element for 0 is 2. So now what it will do is it will remove 1 from the current path, and it will add a 2. So now the our path will be 0 comma 2. Okay, so 0 comma 2. Since because of this line, we will be removing the latest element, and for this the latest element added was 1. So now we will be having 0 comma 2 as the path. Again it will call a 2. Now 2 has only one element, it is 3. So now it will call a 3 by adding 3 to it first. So 0, 2 was the current path, and now 3 is added to it, and now 3 is called. Again 3 was the last element. So this part, that is 0 to 3, will be added to the final matrix, that is the result answer. So this will be added now, and we will move back from here. Now 2 has no more path, so it will move back to 0. And since this was the starting node, we have no other nodes left, so it will move back, and at the end I will be returning the result. This result will be added. Okay, so this result has will be returned back. So this was the same question, but I just added 2 over here just to make you understand a little bit more. So this was the code which I explained to you. So now let's submit it now. So the problem is getting accepted with 100% better than other solutions. So I hope you like the video. And one more thing, this was a void. So make a note of it. So I hope you like the solution. Thank you for being with me, and do like and subscribe our channel, and also do let me know your feedbacks about the improvements I should make while making the video. Thank you very much.